Good morning, students. Differential topic is going on. Already we have seen how to form differential equation. Now another topic I am taking variable separable. What is variable separable? Variable, what are they? X and Y. You collect all x terms and dx one side and y terms and dy another side. Take it both side integration, you will get a general solution. Once again what I told you, collect all x terms and dx one side, y terms and dy another side, take it integration both side, you will get a general solution. It is so simple one. Now let me take some example of this variable separable. Now see, I am taking first question, this one, that is x cube plus x square plus x plus 1 into dy by dx equal to what I am getting, that is 2x square plus x. Okay, fine. Now, so I am taking variable separable, so collect all x and dx one side. So that is I am getting 2x square plus x, the whole upon this goes to denominator, so that we get numerator as dx. Now this is, if I take x square common here, this becomes x plus 1, again this is x plus 1 into dx, that is equal to what I am getting here, dy. Okay, fine. Now this is 2x square and then plus x, the whole upon, if I take x plus 1 as a common, I am getting x square plus 1 into dx, now that is equal to dy. At the time of integration, what I told you, this partial and by parts definitely will link with the differential equation, that's I told you already. Now see here, partial, you have to use partial. Okay, fine. Now I am taking this part, that is 2x square plus x, the whole upon. Before taking partial, you should check degree of numerator and denominator. Degree of numerator must be less than degree of denominator. Clear to you? Now that is x plus 1 into x square plus 1. That is equal to, you know how to do partial. That is x plus 1 plus bx plus c, the whole upon bx plus c, the whole upon x square plus 1. So then 2x square plus x, that is equal to a into x square plus 1 plus bx plus c into x plus 1 into what? X plus 1. Okay, now again 2x square plus x, that is equal to a into x square plus 1 plus b into, if I open this, I am getting x square plus x and then plus c into x plus 1. Comparing coefficient both side, if I compare both side x square, I am getting 2 here, I am getting here a plus b, that is the equation number 1. Now compare coefficient of x both side, what we will get? The coefficient of x, if I compare, now here this 1, that is equal to, what is coefficient of x here? B plus what is c, that is the equation number 2. Now constant, I am comparing both sides. What is constant here? Constant is 0, that is equal to here constant is a plus what? C, that is the equation number 3. Now solving these three equations, we get value of a, b, c. Suppose if you feel problem to solve all these three equations, that's already I explained at the time of this partial vanishing method. Vanishing, what is vanishing method? This is you have to, don't show here. So this solve it inside. Suppose if I give suitable value of x so that value arbitrary constant is 0. I am giving x is equal to minus 1. If I keep a minus 1, the entire term will be 0. That becomes 2 minus 1, that is equal to a into 1 plus 1. So that is, we are getting 2a equal to 1 implies a equal to 1 by 2. If you get a ka value 1 by 2, then you can substitute in this equation number 3. This implies c is equal to what I get, minus 1 by 2. If you know c value, substitute in 2. So equation 2 implies, that is b equal to 1 plus 1 by 2, that is equal to 3 by 2. So solving, you have to simply write here, solving 1 comma 2 comma 3, we get a equal to, how much we are getting? A equal to 1 by 2 and b equal to 3 by 2 and c is equal to minus 1 by 2. Clear to you? Now therefore this integral, I am taking this one, this part. Now that is in 1 upon 2 into integral dx upon, that is x plus 1 and then plus what is the value of b? 3 by 2x minus 1 by 2 upon x square plus 1 into dx equal to integral dy. Now this becomes 1 upon 2, it becomes automatically log x plus 1 and this you can write 3 by 2 into integral x upon x square plus 1 into dx or minus 1 upon 2 into integral dx upon x square plus 1, that is equal to integral dy. Now what finally we are getting log that is x plus 1, and then that is modulus write down plus 3 upon 2. This a differentiation of this is a numerator, multiply and divide by 2 here, multiply and divide by 2. So 3 by 4 into log of what I am getting 1 plus x square minus 1 upon 2 into this is x square plus a square, that is tan inverse x equal to y plus what I am getting c. This is a required general solution. Clear to you? So variable separable is nothing. What is variable separable? You collect all x terms and dx one side, y terms and dy another side, and little bit you apply this either partial or simple integration will come. Okay, if they have given any initial value, substitute initial value so that you get value of a constant, the c value, so that you will get a particular solution also. But this is called a general solution. Clear to you this one? Now let me take one more example of this variable separable. Now see another question, log dy by dx is equal to, that is log, just a minute, log dy by dx is equal to c. Now how to solve this? See, before this differential equation, that's already I told you either log exponential, trigonometric, inverse trigonometric, immediately you should remove, then only you can solve this differential equation. So dy by dx is equal to, if you take this log term to opposite side, e power 3x plus 4y. Now that is dy by dx is equal to, you can make it power is same, then you can break, base is same, then you can break the power. Now bring all the terms, y terms one side and x term another side into dx, take the integration both side. So 1 upon 4 into, this becomes log y, am I correct? This, sorry, e power 4y, e power 4y. Now this becomes, you take it to numerator, e power minus 4y into dy, that is equal to integral e power 3x into dx. Now that becomes, we are getting e power minus 4y upon minus 4. If you integrate this part, e power 3x upon 3 plus what we are getting c. Suppose, just an example I am giving. Suppose if they have given initial value, suppose initial value x is equal to 1, y equal to 1. If they given like this, then you have to substitute this in this solution, general solution. What we will get, e power minus 4 upon minus 4 equal to e power 3 upon 3 plus c. This implies c is equal to e power minus 4 upon minus 4 minus e power 3 upon 3, that is equal to, we are getting c. So therefore particular solution is e power minus 4y upon minus 4 equal to e power 3x upon 3. Then value is, if you want to simplify, you can do simplify this part, or otherwise minus, that is a plus minus e power minus 4 upon 4 and then minus e power 3 upon 3. So this is called particular solution. So if they have given initial value, substitute in general solution, automatically you will get a particular solution. This is called variable separable. Clear to you what is variable separable? So variable separable is so simple topic. So what I told you, that is you have to collect all x terms and dx one side, y terms and dy another side. Take integration both sides so that you get general solution. Next I am introducing another topic, homogeneous. Another most important topic, one question definitely will come, homogeneous differential equation. Now I am telling you how to identify homogeneous differential equation. See, I am giving steps here, then I will give you an example. Step number 1. Degree of each term, I am saying individual term, degree of each term should be equal, step number 1, okay. Now step number 2, collect dy by dx one side, that is bring the differential equation, or otherwise change the differential equation, bring differential equation dy by dx is equal to something, okay. Now step number 3, take out highest degree of x, take out highest degree of x, either it is in numerator or denominator, cancel it, so that you get, take out the highest degree of x from numerator and denominator, from numerator and denominator. That's I told you either it is a numerator or a denominator. That's I will explain you at the time of example. Okay, from numerator and denominator cancel it, so that we get y by x terms or constants, y by x terms, or we will get constants. Clear? Now step number 4, put y by x is equal to v implies y equal to vx, then dy by dx is equal to, that is a v plus x into dv by dx. Now step number 5, substitute 4 in 3, do variable separable, variable separable means collect all v and dv one side, x and dx another side. Do variable separable and integration so that we get general solution. Are you clear what I am saying? It's one of the most important general solution. Once again, I will explain you all these steps at the time of example. Now see step number 1, degree of each term should be equal. Now step number 2, bring the differential equation dy by dx equal to something. Take out highest degree of x, either it is a numerator or a denominator. So where take out highest degree of x from numerator and denominator, cancel it so that you get y by x terms or constants. You will not get any single x separate, single y separate. That is not homogeneous. Here we are confirming it is a homogeneous differential equation. Then put y by x is equal to v. After that you know the steps you are seeing here. Now let me take example that I told you, definitely one question definitely will come from this differential homogeneous differential equation. I am taking first example 2x square into dy by dx, that is equal to 2xy plus y square. Okay, fine. And initial value also given y equal to 0. Solve the differential equation. The question is thus. Now listen. Now see step number 1. Degree of each term is equal. What is the degree here? 2. What is the degree here? This is only one term within product. So you consider as a one term. Degree is 1. 1 plus 1, how much? 2. Now what is the degree of this term? 2. So throughout differential equation degree is a 2. So first step is over, means this is a homogeneous differential equation. Okay, fine. Now come to step number 2. Bring the differential equation into dy by dx equal to something. Now dy by dx is equal to, what we will get, 2xy plus y square, the whole upon 2x square. Clear? Now another step, take out highest degree of x. See, highest degree, this is x square. Either it is in numerator or denominator. Now see this question, the highest degree is in denominator. So I will take from numerator also x square, denominator also x square. That's I have written either it is a numerator or denominator. I am taking here x square, so I will get 2y by x and then plus y by x ka whole square. Clear? Now the whole upon 2x square, it will be cancelled. Now another step, you have to follow all these steps, you will get a general solution. Now put y by x is equal to v, implies y equal to vx. This implies dy by dx is equal to v plus x into dv by dx. Clear? Now here substitute all values, that is substitute step number 4 and 3, that means all the values substitute here. Now v plus x into dv by dx, that is equal to, this becomes a 2v and this becomes v square. Now do it variable separable, so that is x into dv by dx, that is equal to 2v plus v square minus v, that is equal to v plus v square. Now I am doing variable separable, this implies dv upon v square plus v, that is equal to dx upon x. Now I have done variable separable. Now that is up to your choice. If you want to go for completion of square, you can go. Otherwise, if you want to go for partial, you can go for partial. But easiest one, go for partial. So now this is dv upon v into v plus 1, that is equal to integral dx upon x. Now I am doing partial here, 1 upon v into v plus 1, that is equal to a upon v and then plus a b upon v plus 1. Now this implies 1 equal to a into v plus 1 or plus b into v. Now if I substitute in, so if you want to go for comparing both side equation, that is a coefficient of v, I am comparing both side, 0 equal to a plus b. Now that is equation number 1. Then if I compare both side constant, that is 1 equal to again a. You are getting value of a, this implies b is how much? Minus 1. Now therefore integral, the a is 1 upon v and my integral dv minus integral dv upon v plus 1 equal to integral dx upon x. Now what is the integration of this? You should know integration, otherwise it is quite difficult. That's why I told you partial and by parts. At least you should learn partial and by parts from integration. Now that is equal to log x. If you are getting through log, then add to constant also log c. Clear? Now what is the value of this? Is I can write log m by n log v plus 1. That is equal to log, I can write to cx. Okay, fine. Log both side cancel. Let me erase. I have followed all these steps. I think you are clear, so much clear. These steps, don't forget these steps. You follow whatever I have given the steps in every differential equation. You can confirm it whether it is homogeneous or not. Now see, that is log both side cancel. So now v is y upon x, that is y upon x plus 1, that is equal to cx. Now they have given c, if you are simplifying this one, so y upon y plus x equal to cx square. This is our final solution. Now they have given here initial value, that is ye. Means what is the meaning of this? The value of x is, that is given here. What is value of x? E, given as the value of x is e, initial value, y value is 0, y equal to 0. Now substitute here 0 upon something 0, that is equal to c into e square. This implies c is equal to 0. So therefore particular solution what I am getting, the final solution is here. If I keep 0 here, y upon y plus x equal to 0. Clear to you? Clear to you? It is so simple. So try to understand how to do this how to identify homogeneous differential equation. Let me take another example. That's I told you definitely one question from homogeneous will come in board exam. So you have to follow all these steps, easily you will get an answer. Clear to you? Now let me take another example for this homogeneous. If I take another example, that is x into, another example I am taking x into cos y by x into dy by dx, that is equal to y cos y by x plus x. Okay, fine. Now let me see this. What I told you, the degree is, this is 1. You see. Now see the question. This is y upon x. You can decide it is homogeneous. This is a degree 1, degree 1, degree 1. Now I am taking the terms dy by dx is equal to something immediately. Y into cos y by x plus x, the whole upon x into cos y by x. Okay, fine. Now take out the highest degree of x. You cannot take any x, y from inside cos. That's keep in our mind. I am taking x from numerator, so y upon x cos y by x. Now plus 1, the whole upon x into cos y by x. When you are getting this format, therefore it is homogeneous, you can write it as homogeneous. This is confirmation. Okay, homogeneous equation, differential equation. Now I am giving substitution y by x is equal to v. This implies y equal to vx. If I differentiate dy by dx is equal to v plus x into dv by dx. Now substitute all the terms here x into dv by dx, that is equal to v cos v or plus 1 the whole upon cos v. I am taking this variable separable x into dv by dx, that is equal to v cos v or plus 1. This v goes to that side minus v. If I take LCM minus v cos v, the whole upon cos v. It is so simple question. Sometimes integration very easy part will come. Now that is x into, finally we are getting dv by dx is equal to 1 upon cos v, 1 upon cos v. If I do variable separable, that is cos v into dv, that is equal to dx upon x. Take it both side integration. Cos v integration is sin v, that is equal to log x plus c and replace instead of v is y by x. Anything is difficult to tell me? Just you should know how to confirm this is whether it is a homogeneous differential equation or variable separable. First you give priority for homogeneous. You should check degree of each term, automatically you comes to know whether it is homogeneous or not. Anyhow children, I will take more example of this homogeneous in next class. So keep practice, keep on practice and stay blessed. Thank you so much.